Now, question A. The five forces acting on the body on the particle are 2i plus 3j, 4i minus 7j, minus 5i plus 8j, I plus j, and pi plus qj. Now, the particle is, if the particle is in equilibrium, find the values of p and q, where p and q are real numbers. Now, what do? We can write, if the particle is in equilibrium, that means the resultant of the forces acting on it is 0. And we can write the forces in column forms this way: 2, 3, plus 4 minus 7 plus minus 5 8 plus 1 that's 1i plus 1j plus p q equals 0. That's a resultant. Now what do? 2 plus 4 plus minus 5. 2 plus 4 is 6. 6 minus 5 is 1. 1 plus 1 is 2. And then we have 2. Now let's go to the next one. 3 minus 7, that's minus 4. Minus 4 plus 8 is 4. 4 plus 1 is 5. So we have 2, 5 plus p q equals 0. And that simply means PQ equals minus 2, 5. I'm writing the forces as column vectors, and this means PQ equals minus 2 minus 5, which therefore means P equals minus 2 and Q equals minus 5. And those are the values of P and Q very, very simply. Let's go to question B. What does that say? WXYZ is a parallelogram. Let's have a parallelogram first of all. WXYZ is a parallelogram. Let me just draw it this way. WXYZ is a parallelogram whose vertices are W with coordinates minus 1, 1, X with coordinates MN, Y with coordinates 5 minus 7, and Z with coordinates 2, 4. I hope this is clear. The coordinates of X are MN. Now, the question says find the values of, Roman figure 1 says find the values of M and N. Now, if this is a parallelogram, we know that its opposite sides are equal and parallel. This length is parallel and equal to this length, and this length is also parallel and equal to this length. So that means I can say the length WX is equal to the length ZY. Yes, the length WX is equal to the length ZY. And how do I find the length WX? This is just a concept of distance between 2 points, and that will be minus 1. I can say M minus 1. I can say M minus 1 all square plus N minus 1 all square, or even I can just write it this way. And let me write it that way. M minus 1 square plus N minus 1 square equals, you have to just make sure that you're not making any mistakes, equals the length WX equals the length ZY, and the length ZY is, that's going to be 5 minus 2 square, 5 minus 2 square plus minus 7 minus 4 square. Minus 7 minus 4 square. And before we go to that, let's check this. That's clearer. So now that simply means M, I now have the square root. I have the square root of M. This will be M plus 1. The square root of m plus 1 square plus n minus 1 square equals the square root of 5 minus 2 is 3, and the square of that will be the square of 3 plus minus 7 minus 4 is minus 11. That's plus minus 11 square. Now, if we compare what we have on the left hand side to what we have on the right hand side, that simply means m plus 1 is equal to 3, which means m equals 3 minus 1, which is equal to 2, and n minus 1 equals minus 11. N minus 1 equals minus 11. Let me check that again. That's correct. And that simply means n equals minus 11. This is equal to sign. N equals minus 11 plus 1, which means n equals minus 10. And those are simply the values of m and n. M equals 2 and n equals minus 10. And now let's go to Roman figure 2 of the same question B. It says find the unit vector in the direction of xy. We can sketch that. Let's sketch that. I'm only going to sketch the vectors. OX and OY. OX is, now I know now that x with coordinates mn is now the same as x, because I know that m is 2 and n is minus 10. That means the coordinates of x are now 2 minus 10. So that's what I'm going to use to sketch it. 2 minus 10, that's going to be, if this is 2 and this is minus 10, it's just a sketch, then this will be the vector OX. That's OX. And that means it is 2i minus 10j. Now how do we sketch the vector OY? What are the coordinates of y? The coordinates of y are 5 minus 7. So 5 minus 7, that means 5 on the x-axis and minus 7 on the y-axis. So I can do that this way. 5 minus 7. Okay, let me even do this. Let me put this here. This is 2i minus 10j. And the vector OY will be this, 5 minus 7. Let's make that OY, which is 5i minus 7j. And now, what is the vector xy? How do we find the vector xy? This is the vector xy. Let's do this. This is the vector xy. Movement from x to y. Yes, that's the vector xy, which means xo plus oy. The vector xy is the vector xo plus the vector oy. And that simply means that xy equals xo plus oy. And we know that xo is minus ox, and that's equal to minus ox plus oy, which simply means minus into bracket. Ox is 2i minus 10j, minus into bracket 2i minus 10j plus oy, which is 5i minus 7j. Oy, which is 5i minus 7j. And that's equal to minus 2i plus 10j plus 5i minus 7j, which is equal to minus 2i plus 5i is 3i, and plus 10j minus 7j is 3j. So that's the vector OY. Now, the unit vector in the direction of, that's the vector XY rather. This is the vector XY. I need to write that the vector XY is therefore equal to 3i plus 3j. Now we want to find the unit vector in the direction of xy. Let me write it this way. Xy cap. The unit vector in the direction of xy, which is xy cap, is given by the vector xy itself divided by its magnitude. divided by its magnitude. How about clear? Divided by the magnitude of the vector xy. And that's equal to the vector xy is 3i plus 3j, while its magnitude is square root of 3 square plus 3 square, which simply means 3i plus 3j, 3i plus 3j all over root 3 square is 9 plus another 3 square, which is also 9. That's root 18. So that simply means, and we know that root 18 is 3 root 2. So that means 3i plus 3j divided by 3 root 2, which is the same as, we can write it this way, 3 over 3 root 2i plus 3 over 3 root 2j. And that simply means that's equal to 1 over root 2i plus 1 over root 2j. And that's a unit vector in the direction of xy. That's it, very, very simply.